You got up to number 45. When you got up through number 45, with any luck, you might have found one of your zeros to be at 4, I think.
Yeah.
And then you wound up with some really crummy fraction. What happens here was
Attention students, school pictures are in. They are being handed out in your PE class. If you do not have a PE class, please see Mrs. Thomas in the main office. All student pictures are in. PE or the main office of Mrs. Thomas.
Normally when we have taught this section, and you've heard me come back and forth to this topic before. This chapter is chapter 10. We usually do this one about halfway through second semester. So this is usually right around fourth quarter, when the start of fourth quarter when this stuff hits. Now, by that point in time, you guys have seen just about all the cool, funky algebra tricks that you would be able to use by now. In number 45, there's a little trick when it gets down towards the end. If you're able to come up with one of the zeros being at 4, then you had some weird factor like 34x or plus 56 or so on and so on. There is a way to find that other zero. It's called synthetic division. What? Yeah, and that way, what I'm saying here and what I'm getting at is it's not the end-all be-all on 45. When I was looking through my problem sets for things that I had done in the past, I had written down 45. I was looking at the solution manual like, oh yeah, 45 comes up with a regular integer. But when you do the problem, when I was doing that last night again, it works out that there is another solution that has fractional answers. I'm not going to make you do anything like that. I'm trying to get you guys ones that have integer values so you don't have to worry about it. Does that make sense? Yeah. All right. So what I want to do here then is just kind of go through a few of these to make sure you got them right.
Yeah, 32. 32 and 45.
Let's start. Guys, let's just start at the beginning. Oh, why isn't that showing up nicely? Yeah, it doesn't like me. That's okay, I'll get over it. Okay. Guys, I don't want to talk over you. Going through these things, there's a couple of ways to set these up. On 15, I know a lot of you guys that had wandered through and Flex had noticed that you were just setting up with substitution right away. Honestly, I would just sit there and just add them together because I've got a negative y and a positive y. It's about the same amount of steps either way. If I just add these two equations together, I get x squared minus 3x equals negative 2. Moving over, x squared minus 3x plus 2 is 0. By doing that, I eliminated the y value. I can solve for x real quick via factoring. You get x minus 2, x minus 1. So for your terms, your zeros, therefore, are 2 and 1. And I did notice this from the people that were popping in and out. When you got your first set of zeros, you were writing them in the set of ordered pairs. Here's 2, here's 1. And then it's just a matter of substituting back in to solve for y. Now, in that original set of equations, I would have set this one equal to y. So it would be 3x minus 7. And it's just a matter of substitution. 3 times 2 is 6. 6 minus 7 is? 3 times 1 is? 3 minus 7 is negative 4. So that's how you get those two ordered pairs in the first one. Yes, ma'am?
Okay, so if you were to do the way you didn't just do, where you like solve for x and y.
Yeah. You should get the exact same answer.
Yeah, I know. That's what I did. But if you like were to fill it back into that one equation, x squared minus y equals 5. Since it's minus y, you have to change all the signs.
Yeah, if you put it into that one, what I would do here is just go x squared minus 5 is y.
Oh.
See what I'm saying?
Yeah.
It's fine. There are many ways to set these things through. It just depends on how you saw it originally. I mean, I know you set it up that way with doing substitution yesterday, and that's fine. Yes, ma'am? I'm getting that. I'm going to go through a few of these, make sure we're doing them all right. Yes, ma'am?
So if you solve for like y to substitute in one of the equations and you get that back to back?
Sure, if you want, that's fine. It's fine. You should get the same answer either way, okay? The only reason I chose that the second equation, because it's linear, it's a little bit easier
Like
to work
if
with.
you were to find y, like in 16, if you were to do the substitution, you would have y squared, could you put that back into x squared plus y squared equals 18, or would you have to fix those? Okay.
You overthought it if you did it that way. Because in the second problem here, here's what I would do. X equals y. Okay? Therefore, y squared plus y squared is 18. I'm just substituting it.
Like I'm saying, if you have two equations and you find one of them for the other one, you have to use it, like,
You can use either one.
you can use the same equation that you found it on. Okay.
That's fine. Here you just go 2y squared is 18. Y squared is 9. Please tell me you did plus or minus 3 for y.
Yes.
Good. Which means that you have two sets of ordered pairs with y values at 3 and negative 3. And this is easy. 3 and negative 3. Yay! Okay?
Wait, you wouldn't go like 3, -3.
What do you mean, why aren't they flipped?
Why isn't it like -3?
Because if y is positive 3, y equals x, so therefore x is positive 3. Y is negative 3, therefore x is negative 3. All right? What was the next one? 27 and 32? The biggest mistake that I've seen so far on 27 is when you substitute in, I would substitute in negative x for y. You get y, or x squared is negative 6x. Okay? You cannot add here, guys. Or I mean, you cannot subtract out an x, because it's x times x for x squared, and negative 6 times x. So you add 6x. So you get x squared plus 6x is 0. And then you have to factor. Factor out an x. You have an x plus 6. Therefore, your two zeros in this case are?
0 and negative 6.
Very good. It's 0 and negative 6. Those are your x coordinates. And substituting back in, hopefully you chose the second equation. If x is 0, what's y? Now, if x is negative 6, what's y? 6. Very good. Those are your ordered pairs. Okay. So when it says negative x, remember, it means the opposite of x. That's what the negative out front means. Just want to think of it that way. Okay? If you have Mr. Thames next year, he'll beat you over the head with opposites. Okay? He has a bat that has the word opposite on it, and he runs around the classroom and chases small children. So if you're short, then he's going to hit you.
Wait,
See the one with like decay? No, it doesn't have decay.
Mr. Thames is 2 doors back. Big guy, kind of grayish, curly-ish hair, goatee.
never seen him before.
He's walked by before. He's what?
Yeah.
Yeah.
That's correct.
It's alright, I just want to learn how to do it.
Because he wobbles a little bit, doesn't he?
Here's what most people screw up on 32. Most people have screwed up on number 32 because of one small thing. When you substitute in, you get 3x squared minus the quantity 2x plus 1 squared equals negative 6. Does everybody agree that that's a junk squared problem?
I don't know.
Yeah.
What I mean by that is this. When you see something in parentheses squared, that means it's junk
Okay, I got you.
times junk. Okay? Just, you have to FOIL out. Don't kill the puppies, what I'm getting at here. All right? So you wind up with 3x squared minus the quantity, 4x squared plus 4x plus 1. That's what it happens when you simplify it out. 2x plus 2x, and then plus the 1. Still equals negative 6. Here's where you guys have screwed up. What's in front of the parentheses here?
Negative.
Negative. Most of you guys only distribute the negative to the first term. You forget that there's two others. Please remember, when you have the negative here, you have to send it to all three parts. That's where most people make their mistake. When there's a negative distributive property, people screw that up time and time again. So you wind up with the following: 3x squared minus 4x squared minus 4x minus 1 equals negative 6. Does everybody agree on the left-hand side here, it just becomes negative x squared? So I'm just going to do this. Send everything to the right. So add everything over. And that way it gets rid of your negatives and it becomes an easier problem to factor. Mr. Davis, come here! They didn't know who you were. This is Mr. Taines.
I am me.
He likes long walks on the beach
I like pina coladas.
and dancing in the rain.
Yeah. But I'm not into yoga. And I have half a brain.
It's a song.
I've lost it. I don't know what he's talking about.
It's a song.
Yeah, song, if you like me.
Here, here's
Pina colada song.
Guess what? I'm not as old as him.
Yeah, well, we know
We know
that.
So you wind up with x squared
I know it from Shrek.
plus 4x minus 5.
Wait, wasn't it
Yeah, that's right. It
plus
was in Shrek, wasn't it?
Wasn't
Yeah.
it plus 5? Because you have to add 6 to both sides?
Oh, yes, it is. Well, I'm adding the 1 to the negative 6,
Oh.
so it's negative. I moved everything to the right.
Oh.
Okay? If you, that's how that worked. So now you wind up with factoring of what times what's negative 5, but you add it together, you get positive 4.
4 and 1.
4 and 1. So we have x, not 4 and 1, 5 and 1.
Yeah, I was gonna say.
Oh, yeah, that's.
Therefore, your zeros for this will be at negative 5 and positive 1. Those are your x coordinates. Okay, those will be your x coordinates. Remember the trick. Throw those in the ordered pairs right away. And I believe one of these problems had a linear part. Yes. It already had y equals 2x plus 1. So we'll just talk our way through it. If y is going to equal 2x plus 1, what's 2 times 1?
2,
Plus 1.
3,
What's negative 5 times 2?
Negative 10.
Plus 1.
Negative 9.
Destiny, you're giving me this crunchy face.
No, I did.
All right.
I was so wrong on this one.
Did most of you guys screw up on that sign? Like I said, most of you guys screwed up on? Jeez, Ben. Yes, ma'am.
Is this like,
Like, I don't even know what we're
I'm going to go over because I'm going to talk a little bit about the hyperbola again. And what was next? 45 was after that, then 46? Hey, guess what? 46 we did in class.
Yeah, we did. Yeah, we did.
yeah, we did that.
Well, I didn't.
Oh, no, I
All right, 47. Ladies and gentlemen, of all 6 of these that you wound up having to do, 47 was the one that took the most work. One of the things I was hoping that you guys would notice is you would think back to when you were doing your stuff that was linear. When we had linear stuff, we had the same sign, same coefficient, we would subtract. Remember that?
Yeah.
And then if it was the opposite sign, same coefficient, we would add. What's different between the linear stuff that you've done in the past versus the quadratic stuff is that not only worrying about coefficients, you're also worrying about the degree. So this would be same coefficient and power. That's what's different now. If those didn't fall into place right away, what you were trying to do when you did linear combinations is you would multiply one equation by some factor to turn it into one of these two scenarios. Remember doing that? You'd multiply a whole equation by 3, you multiply one by -2, something along those lines. If I'm looking at this one, I was hoping that you would notice that the y values, the y squared and the y, had opposite signs. Did you ever notice that? And hopefully you also noticed that if I multiplied the bottom equation by 4, they would be able to drop out. That's the trick to this equation, to this scenario. Multiply the second one by 4. Okay? If I multiply the top one by 1/4, then I'd wind up with fractional amount. I don't want to deal with fractions. See what I'm saying? I'm trying to make it as easy as possible. So in doing this, you get 16x squared plus 4y squared minus 320x plus 64y plus 1600 is 0.
I was thinking about doing that, but it was like, that's just too big.
But it works out really clean. But you're right, you get nasty looking numbers, but the factoring works out real fast when you get going on it. Now, what I'm going to do is just rewrite that top equation just below it, just so you can see how I'm adding these things together. So here's the top equation. It was x squared minus 4y squared minus 20x minus 64y minus 172. So I'm going to add these two together, and I get 17x squared minus 340x plus 1428 is 0. You okay with that? What's the first rule of factoring? Well, we're not take out just lead. That's where you're completing the square, but the first rule of factoring is to look for a GCF. In this case, I'm going to try and see if I can divide everything by 17, and dun, 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 you can. If I factor out the 17, I get x squared minus 20x plus 84 is 0. Since that 17 doesn't have the variable outside, does it have any bearing upon the problem anymore? No. So now we can go ahead and start figuring out what times what is 84 to add together to get -20. Like you probably have no flipping clue. Very good. How did you figure that out so fast?
I just kept dividing.
That's fine. You can use your calculator. What I would have done if I couldn't figure that off the top of my head, use your table. Your table function in the calculator will show you a 0, and you're right, it's 14. It winds up being 14 and 6. Do you guys remember how to do the table? No. All right. In our table, once this loads up, go to your table, we're going to type in, once I get this figured out, go to your table, it was x squared minus 20x plus 84. So if you go right to your table, you're looking for a 0 in the y column. You're looking for zeros in the y column. 6, and then hopefully you would understand that what times what is 84 that you add together to get -20. One of them 6, the other one has to be 12?
14.
It has to be 14. So there's your zeros, okay? So it's x minus 6. Now, the hard part of this problem, I wouldn't say it's difficult, but it takes a little bit of time, is to find the value of y. And if you're not careful with how you substitute in with your parentheses, that's where you'll mess up. So we know that our x terms will be at 6 and 14. Now it's just a matter of going back to one of the originals. I'm going to use the second equation prior to multiplying it by 4. The reason that I'm going to choose that one is that right off the bat, y squared doesn't have a leading term coefficient. It's going to be easier to factor. Do you guys agree with me on that?
Yeah.
So it just looks nasty, but we wind up doing the following. 4 times 6 squared plus y squared, I forgot the rest, minus 80 times 6 plus 16y plus 400 equals 0. I wind up doing that. Remember, when you write this out, notice what's being squared in that first group. It's just the 6. It's not 4 times 6, 20 squared. It's 6 squared times 4. Okay. When you simplify all of that out, I'm not mistaken, you get y squared plus 16y plus 64 is 0. I just did that last hour to double check my work, and I think it was 64. Okay. Now it's easy. What times what 64 do you add together to get 16?
8.
8 and 8. So how many zeros are there for this problem? There's only one y value then. It's at it's y plus 8, y plus 8, which means the 0 is at negative 8. Is everybody okay with that? Yeah. So at 6, it's negative 8. And at 14, it winds up being negative 8 as well. When you go through the whole same scenario, instead of using 6 squared, you do 14. When you do all that with 14, you get the exact same polynomial. Y squared plus 16y. So your other zeros at negative 8. Okay? Does that make sense? It's not that the math here or the problem itself was overtly complicated. It's just that it took a little bit longer to go through because you had to multiply out by that factor of 4. Okay? Any other lingering questions on these that were driving you nuts? I think that's all of them, except for that 45. I'm not really worried about it. What will happen tomorrow is that I wrote up on the board, you guys are going to have it's the Quizam. I don't know.
It's between a quiz and an exam.
So a test.
You can call it a quest or a Quizam. I'd probably call it a Quizam this time.
It sounds cool.
Because we're not on a quest. We're not out to see the wizard.
It sounds like a word that could be like in a comic, like Quizam. Like in yeah.
It's between a quiz and an exam.
Yes, we have an assessment tomorrow. Anyway, it's the hyperbola.
It's what's on the board.
Yeah, I know. Hyperbolas and systems.
That's his answer. There you go. Yes.
4 questions.
4 questions.
4?
There's only 4 questions on it. But remember, when you're dealing with the hyperbola stuff and we're doing the graphing, I'm going to ask you, where's your center, your vertex, all that kind of fun stuff. Yes, ma'am?
Is it going to be worth less than the last one?
I don't remember how many points this was total.
4 points.
Yeah, it's worth 4 points. You either get it right or wrong. Yes, ma'am? Like I did last time? Yes, I will give you graphs. Yeah, it'll mirror out to what it looked like last time, where I'm going to ask you centers, vertices, foci, all that stuff. With hyperbolas, you have to remember about slant asymptotes, run into the slopes, diagonals. Okay. Yes, ma'am.
So is it going to be like half hyperbola, or like 3 hyperbola?
I don't know. I haven't completely finished yet, but I know what it's going to look like. All right. It's very straightforward, guys. It's very straightforward. They're really, you guys can use your regular 84 calculators. It's not that big of a deal because I know sometimes if it gets down to the systems, if you have a factor, it's okay to use that for the table stuff. I will give you the equations for the hyperbola, the generic thing, because I know some of you guys with the Inspire calculator with the 84 faceplate, you guys don't have the app, but some of you guys do have the app. So I will provide that, what it looks like on the app itself, just like I did last time for the hyperbola, and go from there. My guess is that it probably won't take you guys more than 25 minutes. It really shouldn't. Okay, it really shouldn't. These things are extraordinarily straightforward.
Wait, Joe, we have the whole period, but will.
I'd like you to get it done because I want to try and start that 6-1, which is just all review of just a couple of properties. Okay? Izzy,
Oh, you answered
as far as other questions to look at, my best guess, I mean, we kind of have picked and choose out of all the decent ones that work. If you look in the, oh, where is it? If I look in, yeah, I got quite a bit of file. Well, I PDF the whole book, so. Your book is 900 pages. If you go through into that chapter review, excuse me, really the only problem that is a hyperbola is 35, where you have to complete the square. And here's some focus and vertice problems with hyperbola, but they're not shifted. So that's just your general idea. And then there's a couple of systems problems. I don't think these system ones were that bad. This is just substitution, subtraction, and addition. And these would drop out real fast. So even into here, what's that? Genesis.
Is there like a way to tell which? No.
Not really. I mean, if you go back to the idea for which ways to go for the systems to be the easiest way, if you remember kind of the idea of when you did stuff linear, you down squared terms, if it was the same coefficient, same sign, subtract. Same coefficient, opposite sign, you add. It's always easier to add because you don't have to worry about distributing the negatives. You're looking to get things that have the same coefficients with different signs, they add them together. But if you have, let's say, let me pull this back up. If I'm looking at, sorry, I didn't clear out as nice as I hope. If I'm looking at a problem like this, and I'm trying to decide what's going to be the easiest way to go about it, if you look at the two equations, the top one has an x squared, the bottom one doesn't. Since the top one has an x squared and an x value, it's going to be easier for me to deal with x squared and x's via factoring. So that means I want to get the bottom equation solved for y. So when I do that, I'll get y equals negative 3x plus 6. And then I would substitute that up here and put it in terms of it. Because that way I have all the same variable in one string. Okay? Same idea when I get into, it does it all the time. Try that again.
Maybe you have to go like fast.
No, it's not working. It's annoying when it does that. Then try not to mess up with the signs. Oh, yeah, maybe that was work better. Third time's a charm. If I'm looking at this one, what are you going to do to this? Why?
Because it's negative 16, pull out the y.
Does everybody see how, in this case, if I add them together, the y squareds will go away?
Yeah.
That's how I would set that one up. I would add them together, I would solve for x, or in this case there might be two different x's, then just substitute back in and then just solve for y squared. You'll have to take a square root, you'll probably notice you'll have two answers at that point as well. But does that make more sense for your question? It's a lot easier than you think. This is easy.
Wait, I don't understand the difference between when you, like, with that kind of thing, when you add them and when you subtract them.
Notice that.
Yeah.
If I add them together, do they go away?
Yeah.
Okay. If this was, then what would I do?
Subtract.
Then they would go away.
Okay, so
then all the
if
answers would
not,
also
say,
go away.
never
Maybe they would go away.
mind.
They go away. Because
It's using that elimination like that.
16
Yes, ma'am.
plus 16
What is the third way?
No,
It's
no,
like
wait.
the adding, subtracting, and the substitution.
The third one is that linear, it's that combination where you have to multiply it by some factor. Remember that number 46, we multiplied out by a factor of 4?
The one that we just listed.
Yeah, a little while, 47, yeah, 47.
Okay.
This nasty one. remember how we had to multiply this one by 4? We turned it into one of these styles. We took-
Mixing both problems.
Yes, yeah. You're taking it and multiplying it by a factor to turn it into an addition or a subtraction problem. That's kind of the other way. Okay? Well, you had your hand going up there a second ago too.
I did?
I thought you did.
No.
Well, I didn't want to help you then.
All right.
Glad we had the conversation.
Sounds
And-
good.
Got nothing. Other questions? It's exciting. You guys are going to be fine. You guys have been knocking these hyperbolas out of the ballpark. They're- You guys did, on average, really well. Oh, the logic problems? Yeah.
Lots of problems.